Today I'll be explaining the one of the concept that comes into foundation design, which is soil pressure. We will understand this concept in depth and we will also have a look how to visualize the results using Python in the end. We will also use AI in order to understand the data and interpret the results. We will also see how you can even create a web page based on these results and how you can even try to see different changes in the sizes of the foundation and how they affect the soil bearing pressures. So basically, the foundation design is dependent on four parameters. The first parameter is your soil pressure, second is your one-way shear, then punching shear and bending. So in this lecture, I'll be explaining you soil pressure and one by one in the next series of lectures, I'll explain you the next one. So how we will do, we will explain one of the checks in the foundation and we will see how to interpret its results. And after the interpretation, how you can visualize the data using Python and how even you can create the overall web page for the design with respect to particular check. Okay, so let's start with the soil pressure. So for soil pressure, uh, let's say there is an isolated footing which is having a load of around P. P is an axial force which is coming on the footing. M is the moment which is coming on the particular footing. And because of this axial force and moment, there are some pressures which are generated on the base of the footing. These are the pressures that need to be resisted by the foundation in order to take the load. So now, let's say this is the plan view. There is an axial force of P. The moment is acting along My, along Mx. And based on this data, there is an pressure, a uniform pressure, which is getting generated, which is P by A because of the axial force. And because of the bending moment, there is a linear variation of the pressure distribution because of the moment. So we will take that as M by Z. Z is your section modulus. M is the moment that is getting applied on the footing. So if you combine these both, you will get the minimum and maximum pressure which is coming at the base of foundation. This is your P by A plus M by Z, and this is your P by A minus M by Z. So on the one side, if you see, because of the moment, compression is coming because of the moment, plus already the soil is compressed because of the axial force. So if you add on one side, this will add up and this will give you the maximum pressure. Okay, there is one thing that I'll need to update. This will be your plus, and here you will need to make it minus. So this will be your minimum pressure. This will be your maximum pressure. So because of the axial load and moment, there will be compression created because of the moment on one side, which will add up. And on one side, tension will be created, which will be deducted from the pressure created because of the axial force. So once you do that calculation, you will get a pressure distribution diagram, something like this, which will give you your sigma max and sigma minimum. Your maximum pressure should be less than or equal to your soil bearing capacity. This soil bearing capacity you get from the actual site testing. There are different soil testing results carried out by geotechnical engineers, which gives us the value of the SBC. And based on our analysis, we need to check whether this value is less than or equal to the maximum pressure that we are getting. Once we have checked the maximum pressure with respect to soil bearing capacity, then the second check is we need to check whether the final pressure which are coming on the footing, they are not going into the negative side and they are always greater than or equal to zero. So, I mean, if it goes below zero, then we need to perform some nonlinear analysis. And once we perform the nonlinear analysis, we come to know like, uh, I mean, how the redistribution of the pressure is getting done if the soil is not at all in contact with the footing. Let me explain you this concept in depth. Suppose you have a foundation like this here. In this foundation, because of the moment, your pressure is going on the negative side. And this is the particular portion which is going into the negative side. So what you can interpret from this particular part of the footing is not at all in contact with soil. Now you just assume if something is not at all in contact with soil, will there be any pressure coming on the particular footing? Absolutely no. Because of this no pressure which is coming on one side, what will happen? The soil will redistribute the pressure as per the contact. So this overall portion of the soil distribution will make adjustment in its own based on the nonlinear analysis, which will give us the actual pressure distribution diagram. So as you can see, if some part is not at all in contact, it will redistribute, and again the pressure diagram will come something like this. So this is the reason we need to perform nonlinear analysis. So that's what many engineers do. They actually run the linear analysis first. They check whether the negative pressures are coming into picture. If yes, they run the nonlinear analysis and the redistribution of pressure happens. And with respect to those values, they check for the soil pressures. Now, this was the overall concept. Now, I'll explain you in Python. This can be very well interpreted. I'll explain you in Python how we do it. So, I mean, you can use ChatGPT or you can use any other AI tool in order to generate the code. You can simply give a prompt, like for the soil pressure. If I need to visualize the data and I need to create a website on my own, where I can give the inputs of axial forces and moments and I'll get the results. So you can even do that on Python. So once you do that, you will get some code. I'll help you understand this code, not in depth, but as a structural engineer, we just need to use the tool Python in order to understand the results. So that's what we will do here. So first of all, if any web-based platform you need to create, this is the best library, Streamlit. Streamlit is a particular library which helps you to create a web page without using any kind of HTML or any other platform which requires other tools. So Streamlit helps you to create a website on your own just by using Python. Matplotlib is a library which you use in order to plot the graphs and show the data visualization. Same is there for Seaborn. Seaborn and Matplotlib both are the libraries for data visualization. Math and NumPy, these are just the libraries that we need to import for calculations. So now let's go ahead. These are just the particular coding parameters that we will need to import to do our calculations. So now coming towards the next part, these are the calculations. Like this is calculating the moment of inertia. Once you get the moment of inertia, this is calculating the pressure which is getting generated because of the axial force. This is the pressure which is coming because of the moment along x-axis. This is y. Then this will p minimum, p max. This will do the calculations. So basically, this is the overall parameters that we are setting into Python for our next set of actions. So these are some of the variables which are getting defined here. After that, Streamlit, this is the overall set of code which we will need in order to show the data on web page. So like you will get the title like this. You will assign what is the axial load, what is the moment. This is the set of input data that we will need to give on the website. Then the calculations will be performed. After that, there will be some display of the numerical results that will be done. Then you will get the pressure field visualizations, and just you there is no need to understand this code in detail. You will get this with a single prompt from ChatGPT. You can take that code, you can just feed it into your I would say VS Code, which will be the best platform for it. Let me know in the comment box if you want these things to be understood in detail. I'll make a special video for the same. So once you run this particular code into uh, Python or VS Code, you will get a website something like this. And this is the smartest way to learn something. Like here, you can give some data like the axial load, moment, footing width, your moment in X, moment in Y, whatever the soil bearing capacity, footing length, all the data. Once you just give this data, you will get what is the average pressure coming, what is the pressure because of moment coming, and what's your minimum and maximum pressures. It will also tell you the utilizations, and this is the representation that you get from the Python. It will give you how the variation of pressure is happening because of the load on a particular footing with actual heat maps. And it will also give you a graphical representation with respect to the position. So this is something which is done by Matplotlib as well as the Seaborn libraries that we used. And these are just the basic calculations that we performed. So I hope this video was helpful for you in order to understand concept wise, as well as I would say understand how you can take the code and whatever calculations that you are performing, how you can actually use Python in order to visualize the data. Thanks a lot.